We're told the ideal human diet is balanced, plant-heavy, and full of variety. But if that's truly what our bodies need, why do some people see such dramatic results when they do the complete opposite and eat only meat? Now, most explanations focus on nutrients or anti-nutrients, and while those things do matter, they're not the core reason. The real reason the carnivore diet works so well has less to do with meat and more to do with how human biology actually evolved. For a long time, Homo sapiens coexisted with other species of humans, like Neanderthals, where stable isotope analysis made it very clear that all species of humans, at the very least, prioritized the hunting of large ruminant animals. Although several human species were considered apex predators during this time, Homo sapiens ultimately outperformed the other humans. And it wasn't because we were physically stronger, but likely because we had a cognitive advantage. So even among apex predators, Homo sapiens appear to have adapted most successfully to this role or carnivore niche. Now, although we don't look like other apex predators, this could actually point to why we truly came out on top. As our brains became our primary advantage when it comes to hunting, by allowing us to communicate, create tools, plan, and strategize, our bodies had to compensate. Our brains grew bigger, our muscles and gut shrank, increasing our dependence on nutrient-dense, highly bioavailable animal foods, especially fat. This trade-off is often referred to as the expensive tissue hypothesis. Because we have very energy-hungry brains, it should be no surprise that humans thrive on a very fat-heavy ratio when only eating meat. Generally, 60 to 80% of calories coming from fat, with the rest from protein, seems to be the sweet spot. Now, it is no coincidence that most very large ruminant animals contain roughly this total ratio throughout their whole bodies when eaten nose to tail. But compared to other carnivores, human rabbit starvation, essentially malnutrition from not enough fat, can happen very easily if fat consumption drops below this range. Our stomach is extremely acidic, typically ranging from a pH around 1.5 to 2, which is as acidic and oftentimes more acidic than other carnivores. Our cecum is very small compared to animals meant to digest plants, which usually have massive fermentum chambers that allow them to derive the majority of their energy from fiber. So unlike animals meant to eat plants, we lack the machinery to fully break down plants properly. At the same time, humans have a practical ceiling for protein intake, meaning we cannot rely on lean meat alone for sustained energy. The fact that we can't ideally rely on plants and have a low protein ceiling, the main viable energy source for humans is fat. So if fat was foundational to human evolution, what is it about fat that makes it so good for our brains? The brain is roughly 2 to 3% of our body weight, but uses 20 to 25% of our energy, meaning it needs a consistent, stable, and reliable fuel source. Although most of our tissues can use fat directly, the brain cannot use long-chain fatty acids in their raw form. Instead, our liver converts them into ketones, which can easily cross the blood-brain barrier and can be used as fuel by neurons. Roger Seymour noted that not only did our brains grow by 3.5 times, but blood flow increased by 6 times. Therefore, the fact that ketones can produce more ATP per unit of oxygen under certain conditions makes them a very compelling fuel source for an organ that is so oxygen dependent. After all, unlike protein and fat, which are essential nutrients that we must eat, dietary carbohydrates, which I'll break down into glucose in the body, are not essential nutrients. And any small amount of glucose that we do need, your body can create from protein and fat through gluconeogenesis. Generally speaking, the body will clear and use fuels that cannot be safely stored in large amounts first. This is why if you drink alcohol, the body will clear ethanol first. It will then use glucose or store it as glycogen, since circulating glucose must be tightly regulated as it can bind to proteins and cause glycation, and fat is used last as it can be stored and mobilized efficiently with relatively minimal immediate disruption. The Randle cycle describes how fat and glucose compete as fuels inside the cells. When one is elevated, the other can be downregulated. This may seem counterintuitive because it can look like the body is creating dysfunction, but when you realize that carbohydrates in the diet were likely seasonal and geographically variable, rather than constantly abundant year-round, it makes sense that the body evolved the ability to switch fuel use depending on availability. In that context, temporarily prioritizing one fuel over another would have been advantageous. So given that almost all of our dietary carbohydrates come from plants, they aren't just not essential, but they are likely suboptimal. And when it comes to plants, there's more to them than just being a suboptimal fuel source. Just like we had our own way of evolving to spread our seed and reproduce, so do plants. But since they can't defend themselves like animals can, They must rely on chemicals, some of which are commonly referred to as anti-nutrients, and just as the name suggests, these can interfere with the absorption or utilization of certain nutrients. I go into this more in depth in this video, but essentially there are chemicals in plants that are there to prevent the absorption of nutrients. All living things do contain some type of nutrition as they are alive, but it is in the best interest of plants to prevent you from being able to absorb them. Not only this, but they can prevent the absorption of the other nutrients within the other foods that you eat with them as well. Before animals came on land, plants actually didn't have much competition, but now we are essentially in an evolutionary arms race with plants. Plants create toxins, animals create counter adaptations, and plants become more toxic. This is why if you were stranded in a forest right now, your best bet would be to hunt animals rather than gather plants, as you likely wouldn't last very long just surviving on plants. But this doesn't mean that all plants are poisonous, but it does mean that they contain compounds that must be processed, like cooking, soaking, or fermenting, to be tolerated or adapted to. This is why even herbivores can only eat very specific types of plants, because those are the only ones that they have adapted to eat, and can only break down those specific anti-nutrients within those specific plants. Humans historically have eaten some plants throughout evolution, but it was mostly fibrous tubers when food was running low, but we really only introduced significantly more plant matter into our diets when we started farming roughly 10,000 years ago, which is a blink of an eye in terms of our evolution. We could now selectively breed the less toxic plants, but given the rise in consumption, this still happened to coincide with the rise of modern day diseases, brain shrinking, and the deformation of the jaw and crooked teeth. And out of all things coming from plants, people often say that we need fiber, but it is actually a non-essential nutrient and arguably has more downsides than upsides. A common misconception about fiber is that it prevents constipation, but this study found that in those with idiopathic constipation actually did far worse the more fiber that they ate. In the group that completely eliminated fiber, every single one of them relieved their constipation. Fiber is actually completely indigestible by humans. It sits in the gut and partially ferments, producing short-chain fatty acids like butyrate, which people claim feed the gut. But you don't need fiber to get this benefit. You can get butyrate directly from animal fats like butter, or more importantly, by eating a meat-focused, ketogenic-like diet that stimulates the production of beta-hydroxybutyrate, a ketone that provides many of these same benefits and likely more. This means that you can get a lot of the benefits associated with butyrate without any of the downsides of fiber, which can actually act like an anti-nutrient and interfere with digestion as we cannot properly break it down. And it's not just fiber that seems to be suboptimal or function differently on a carnivore diet, but many vitamins and minerals like vitamin C for example. When people hear of the carnivore diet, many instantly think that it is a quick way to get scurvy, because we're often told that meat doesn't contain any vitamin C. So when you hear of scurvy, you might think of these sailors from the 15th to 18th century that suffered from bleeding gums, extreme fatigue, joint pain, and eventually death due to vitamin C deficiency. But here's what most people don't realize. Carbohydrates and vitamin C share similar pathways into the cells. Both rely on related glucose transport mechanisms, meaning glucose can compete with vitamin C. So one way to potentially improve vitamin C efficiency is to lower carbohydrate intake, because meat does have a small amount of vitamin C. This is where the sailors likely went wrong. They weren't eating fresh meat, they were eating preserved foods like hardack, dried grains, and aged meat, which contain little to no usable vitamin C. At the same time, they were consuming refined carbohydrates, which drastically increased their vitamin C requirements. And a similar thing may be happening to other vitamins and minerals on the carnivore diet. The RDA, or recommended daily allowance, is based on a standard American diet full of plants and carbohydrates. But on a ketogenic or carnivore diet, your metabolism functions far differently. So nutrient requirements are likely not fixed, but maybe more so dependent on the metabolic environment that you're in. But even beyond this metabolic context, animal foods are among the most nutrient-dense and bioavailable foods available. Counter to what most people think, meat is actually far more nutrient-dense than most plants you can find, and the abundance of vitamins and minerals that you get from meat aren't being blocked by anti-nutrients. So given our reliance on nutrient-dense, bioavailable foods, if we take the expensive tissue hypothesis into account, it is no surprise that we thrive on eating meat. Now there is some important nuance to this, because there is a way that we went about eating meat during most of our evolution. For example, this doesn't mean that we should only eat organs which are extremely nutrient dense, as this can lead to hypervitaminosis or toxicity. If organs are eaten, they should be very sparingly, and in the amounts that you would find relative to a whole animal. Because after all, the carnivore diet works best when it is done in a way that is most congruent with how we have eaten for most of our evolution. Mostly muscle meat, the connective tissue, and the associated fat, with very minimal or no organs. So what is the real reason the carnivore diet works so well? Well, it is the closest modern approximation to a proper human diet. One that aligns the closest to what our biology has evolved to expect.